Good morning, everyone. My name is Abdelazim Ibrahim. I'm a PhD candidate at the Hong Kong Polytechnic University. Currently, I am in attachment program in Delft University of Technology. This research is a collaboration research between the Hong Kong Polytechnic University and Centrale in France. This research addressed the gap in sustainable construction. We tried in this research to how we can link lean construction and circular economy concept, because all the previous work just focus on the fundamental research without any statistical method. Before we start, we need first to see the problem. Mega project, despite their marvels or evolving in the recent years, mega projects still are massive material because the energy sink that look in high carbon emission, waste, and severe community disruption for decades. Because of or due to the linear paradigm, because it take, use, dispose without any recycling. So any new sustainable practice suffer a lot from the high cost perception, because anyone wants to develop any sustainable practice in their project, they see it's the high cost perception, because they focus on three pillars, that economic, environment, and social. So they see it will be more expensive. So this is the synergy between lean construction and circular economy. What about the two concepts? Lean construction, it focuses on how we can optimize the resource, how we can stabilize production flow, and also how we can eliminate non-value added activities. We're using a lot of tools, most of them using to eliminate waste in construction, like cluster planner system, we're using for scheduling, we're using visual management and continuous improvement, and also we use many tools like tech planning, like S3 thinking, a lot of tools we use in lean construction. But for circular economy, it focuses on how we can reorient material flow, how we can to preserve and extend the value for the materials. We use many of concepts in circular economy, like design for disassembly, because we need to put in our mind in first stage how we design the building for disassembly. The connection between the two concepts, recent literature, have a lot of attention. As we can see here, lean construction focus on optimize the process, and circular economy focus on retaining the value of the material. But all the literature, it was focused on the theoretical review-based or qualitative research. Also, there is no any empirical validation of causal circular economy and lean construction integration. Also, one study using partial least square structure equation modeling have been applied only in manufacturing. So in the literature, there is a gap in applied this in construction mega project. So our study, it will be a first study to statistically validated how circular economy enablers will address the lean construction implementation by using partial least square structure equation model. This is our conceptual model that we developed from the literature review. The three main pillars of circular economy enabler related to policy-driven capacity, digital life cycle system, and the economic market enablers, and how they address and help to lean construction implementation. The three pillars for circular economy enablers, first one is the policy-driven capacity that focus on the institutional layer or governance layer, because it focuses on the circular economy guidelines. Second term for digital life cycle system, where is the technology come, like building information modeling, IoT, and material passport. And the final pillar for circular economy related to economic market enablers, because it focuses on the material recycling or design of disassembly incentives and dumping penalties. For the lean construction implementation, it focuses on 6 main constructs because they intersect with each other. As we can see, the first one, customer focused waste elimination, it focuses on many tools like target value design, value stream mapping. For the people involvement, it's focused on Gemba walk, S3 problem solving. For flow and pull system, it focuses on just-in-time, integrated project delivery. For standardization, they're using tact planning, they're using 5S methodology, using many visual management system. For planning and schedule, the most important 2 tools like last planner system. For safety and quality, they used many tools like Buka-Yoka, mistake proofing, root cause analysis, and others. Our methodology, we're using first stage, we did SLR, systematic literature review, from the literature from 2010 to 2025 to map the construct from the literature review. After that, to develop our questionnaire survey, we made a pilot study with 10 senior local construction industry experts. For data collection, we're using Hong Kong as a case study because Hong Kong, it's very popular with high skyscrapers and the mega project. Also, for the threshold, according to the literature, we have found the definition for mega project in Hong Kong and China. They called any project exceed 500 million yuan at the mega project in the threshold. So we collected around 137 persons. After that, we're using partial least square structure equation modeling as a technique we use to validate and test our model. This is the main result. There is 68.3 variants of lean construction implementation come from the 3 pillars of circular economy. As we can see also, the digital life cycle, the circular economy indirect relationship with lean construction implementation around beta equal 0.827, and then digital life cycle, beta, economic market, and the policy, and all the beta inside it. And also, our model gave a good predictive relevance. If we used our model in future, it has a good for prediction. Before we test the structure model or the hypothesis, we need first to test the measurement model. In the measurement model, we're using many tests to verify our model results. First, we're using Cronbach alpha, we're using composite reliability, we're using AVE. Okay. So as we can see here, all the results for Cronbach alpha and the composite reliability exceed 0.7, and average variance extracted exceed 0.5. Also for discriminant validity, we use this to be ensured that every construct for circular economy and for lean construction are distinct, and there is no overlap between the construct between each other, and this is the result. After that, as we can see, this is the hierarchy for circular economy enablers ranking. As we can see, we can find that digital life cycle system as the first rank, then economic market enablers, and after that, policy-driven capacity. To go in deep in the result, we can find that digital life cycle system in the first rank as the catalyst because it resolves the main problem with lean construction implementation related to standardization, because the circular economy from 4D and 5D BIM, material passport, all of this will resolve the standardization of the lean construction implementation. And after that, the economic market alignment also as the sustainer in the second place because it resolves the economic misalignment between the waste till assets or as the resource. The last one is the policy-driven capacity because the policies create institutional legitimacy that allows field teams to embed circular KPIs alongside traditional time costs through institutional routine, operational field metrics, and workforce reasons. As we can see here, this is the implementation playbook. For the policy action, we need to mandate digital passport. For market action, we need to make a contract with the contractor. They need to employ collaborative integrated project delivery framework. And also for contractor action, we need to use policy delivery team must integrate joint circular economy and lean construction implementation. And for future research, we need to focus on longitudinal tracking, cross-country comparison, and the phased BIM IoT deployment, and also using edge-based modeling to simulate material recovery dynamics. Okay, this is the final slide. As we can see here, circular economy, causally powerful, and drive lean construction implementation. The first lean construction enabler is digitalization lifecycle system because it's a primary lever in the ecosystem. After that, the economic market is the second place because it makes linear circular investment financially sustainable. Number 3, the policy establishes the institutional foundation. The remaining of the model, 31.7.24 actionable barriers related to procurement fragmentation, skill gap, missing circular economy, and regulated unevenness. Thank you. Any question?
Thank you for your presentation. Common practice, right?
Yeah.